Okay guys, we are back with example 4, and we are going to work backwards. We're going to write the equation given the graph. So a couple things to point out here. It says write the equation of the cubic polynomial. So you know if it's cubic, our polynomial should have x to the third, and it wants it in standard form, so not factored form. A few things to note here. If the function crosses the x-axis, it has odd multiplicity. If the function bounces off of the x-axis, it has even multiplicity. Alright, so the first thing we want to look for are the zeros. So here is a 0 at -2 and our other 0 is at 1. This is crossing the x-axis. This is bouncing off of the x-axis. So I know that when I write my factor, that this has to, because it's crossing, it has to have odd multiplicity, and because it's bouncing here, it needs even multiplicity. So also, so think of it like this. If my 0 is at x equals -2, my factor is going to be x plus 2. If my 0 is at, this is +1, sorry. If my 0 is at +1, then my factor is going to be x minus 1. Now let's go write our polynomial. So it says if it crosses, it's going to be odd multiplicity. So I'm going to take that x plus 2, and I'm going to leave that to the first power because that is odd multiplicity. Then I'm going to take that x minus 1, and it needs to be even multiplicity, so an even power, so I'm going to square that. Now I could make this be the third power. That would still be odd multiplicity. I could make this be the fourth power because that would be even multiplicity. But overall, I've got to have a cubic function. So I know this is x to the first and this is x squared. And if I add those exponents, that's going to give me a cubic function. So now we want to multiply that out. So that's going to be x plus 2 times. So you can use your shortcut, you can FOIL, you can distribute. You're going to get x squared minus 2x plus 1. Then you can distribute, box, whatever you like to do. I'm going to box. So we'll have x to the third, -2x squared, and x on our first row, 2x squared, -4x, and 2 on your second row. These guys are going to cancel out. Here's like terms. So our polynomial is going to be x to the third minus 3x plus 2. Okay? And then you could graph that to make sure that it does match your graph. So the important thing we had to pick up here is that it was a cubic function. Okay, next is your turn. I'm just going to do that with you real quick. So we have to write an equation for a quadratic polynomial. So you know if it's a quadratic, we've got to have x squared. And if you look, this is bouncing off of the graph at 3. Okay, so we have a root at x equals 3. And because it's a bounce, I need even multiplicity. So my factor would be x minus 3, and if I need even multiplicity, I could have any even power. However, because it says quadratic, my power is going to be 2. So then we want to expand that, or do your shortcut. So it's going to be x squared minus 6x plus 9. Last, we have a word problem. It says a person is going to make a box by taking a rectangular piece of cardboard, which is 12 inches by 16 inches. So let's just go ahead and give ourselves a visual of that. So we've got a 12 by 16. We're going to cut squares out of the corners, and then we're going to fold the edges down. So we're going to cut squares in all 4 corners. Write an expression for the volume of the box in standard form. So they didn't tell me how much we're cutting in on each corner. So I'm going to call this x, and it tells you they're cutting squares. So I know the dimensions of that is x by x basically. So all the way around, this is what you see. And it says express the volume of the box in standard form. So once you cut those corners in and fold them down, you've now made this a 3-dimensional shape. So our volume formula for that is length times width times height. So let's see what we know. Our height is going to be the amount of the cut that you make for your 4 corners, because once you fold those in, you've then created the height of the box. So it's x. Our width, so our original width was 12, but then if I cut nx on this side and nx amount on this side, we've really taken away 2 x's. So 12 minus 2x, and then our length was originally 16, but we cut in x inches here, x inches here, so we really took away 2x inches for the length. So now I'm going to take that volume formula and I'm going to sub in what I know. So I know all 3 of these now. And it doesn't matter what order we put them in because it's all multiplying. So then I'm going to distribute. So 12x minus 2x squared times 16 minus 2x. You can either box it, you can distribute, you can FOIL. Okay, so just to keep it nice and neat, I'm going to come over and box. So 12x times 16 is going to give us 192x. This will give us negative 24x squared. This will give us negative 32x squared, and then 4x to the third. So we do have some like terms here. And you want to put it in descending order. So our volume would be 4x to the third minus 56x squared plus 192x. So that would be the expression that represents the volume of that box.